All right, let's finish up our laws of exponents. So in the last video, I just kind of reviewed the first 4 laws that we learned in class. Product rule, zero exponent rule, what to do with negative exponents, and then the power rule. So the next thing we need to do is called the quotient rule. So let's write that in. And P.S. if I ever go too fast, just pause it, obviously. Copy whatever you need down. It's weird because I have none of you to ask questions to or look at. So I'm talking to myself right now. Quotient rule. Quotient. Quotient is opposite of product. Product means to multiply. So what is the opposite of multiplication? Division. So we're going to do some dividing here, and we're at the point where we don't really use the division sign. We use a fraction bar because fraction means division. So if I have x to the power of a, so that's our numerator, x to the power of a over x to the power of b, we have to know how to deal with that, okay? So like I said, quotient is opposite of product. So in the product rule, we said when you're multiplying and the bases are the same, we keep the base and add the exponents. So that's key there, okay? So they kept the x and then they did a plus b. Well, if the opposite of product is quotient, the opposite of adding the exponents would be to subtract the exponents. So we keep the base and then we actually subtract. Now, does it matter which way, a minus b or b minus a? Absolutely, it matters. You take the top, subtract the bottom. Okay, so that's quotient rule in a nutshell. Okay, here's some examples. So I have x to the 5th over x to the 3rd. X to the 5th divided by x to the 3rd. Now let's actually expand this out so we can kind of see it visually. X to the 5th power, how many x's are being multiplied there? There's 5 x's being multiplied. Denominator is x cubed, or x to the 3rd, has 3 x's being multiplied. So we can actually kind of simplify this down a little bit. So like x over x, look at these tiny little sticky notes, aren't they cute? X over x is the same as like 4 over 4. Well, 4 divided by 4 is 1. Hopefully you didn't say 0. Anything divided by itself is 1. So x divided by x, 1. Y divided by y, 1. Okay? So right here you have an x over an x. So that kind of cancels to a 1. X over x cancels to a 1. X over x cancels to a 1. So if you kind of cancel out what you can, let's see what we're left with. I got 2 x's on top. X times x is x squared. And what's left on the bottom? It's tempting to say nothing, but I can't put 0 down there. That's illegal. So since everything cancels out, it's really just a 1 under there. But I don't really need that one, so my final answer is just x squared. Okay, so we still got x squared by expanding it out, but we also could have just done 5 minus 3 is 2. Got x squared. Here's number 2. X to the 10th over x to the 3rd. So imagine you have 10 x's being multiplied, and then you have 3 x's being multiplied. You're going to cancel out 3 little x over x's. So what would you be left with? You'd be left with x to the 7 on top. Everything would be cleared out of the denominator, so it's really just 1, which is just x to the 7th. So we can just do 10 minus 3, 7. Okay, let's do another one. X to the 5th over x to the 8th. Bases are the same, so I can subtract the exponent. So what we're doing here is we keep the base, and then we take the top exponent and subtract the bottom exponent. 5 minus 8. 5 minus 8 is not 3, it's negative 3. So that's x to the negative 3rd power. But uh-oh, do I want to keep this negative? No, okay? We have to change that to a positive exponent. So what do? Ask yourself, what do we do to take care of that negative 3 as the exponent? Well, I gotta do 1 over x to the positive 3rd. That's my final answer. Okay, so the rule here, let's go ahead and write kind of a little rule to ourselves. Let's say this, we'll start with when you're dividing, because we have to make sure this is only for when you're dividing. When you're dividing, and the bases are the same, comma, when you're dividing and the bases are the same, and then ask yourself, what do you do with the exponents? You subtract them. Subtract the exponents. So pause the video if you need to catch up. I'm gonna go on to number 4 though. Number 4, big old fraction bar. On top you have x to the 5th, y to the 3rd, and you know what, just for fun, in front of that x to the 5th, let's put an 8. Denominator, you have 4, x squared, and a y. Okay, so let's bump this up a little bit. Now we are dividing. So right away I see 8 divided by 4. So what's 8 divided by 4? 2. Next I deal with my x's. We gotta do same base. So I keep the base, I keep the x, and now I just subtract the exponents. 5 minus 2 is 3. And then I deal with my y's. Keep the base the same, and then I do 3. Now is this 3 minus 0? What's secretly on that y? Secretly on that y is a 1, so 3 minus 1, 2. All of my exponents are positive, so I'm happy. That's my final answer. Okay, and number 5. Three. 24 is going to be on the bottom, so I already want you to kind of think about what that's going to be. Go back to the top. You got an x and a y cubed, and then on the bottom you have an x cubed and a y cubed. Okay, so I like to deal with my numbers first, my coefficients. 3 and 24. I hope the number 8 comes to mind, but I hope you don't write an 8 right here. 3 over 24 is a number less than 1. It's going to be a fraction. So 3 divided by 3 is 1. 24 divided by 3 is 8. So that's 1/8. Okay, now let's deal with our x's. So I keep the base. There's a secret 1 up there. 1 minus 3 is not 2. 1 minus 3 is a negative 2. With the y's, keep the base y. 3 minus 3 is 0. Okay, so let's go ahead and write our final answer down here. So the 1/8 is going to stay a 1/8, but I'm going to extend this out. X to the negative second power. I can't leave this negative. Okay, so where does it go? Do I do x squared on top or x squared on the bottom? Well, I have to actually change it. I have to change it to a fraction, so I have to change it to the denominator. So x squared goes down here. And what about y to the power of 0? Well, anything to the power of 0 is 1, so I don't even really need to write a 1 because I already have it up there. So that's your final answer, 1/8 times x squared. Okay. And then I wanted to do, hopefully it's not too loud, it's pouring rain outside. I want to do a few more problems in your notes. So this is going to be called, what am I going to call this? More on negative exponents. And power rule. So I just want to do a few more problems and talk through a few more things. So if you watch the Khan Academy videos about negative exponents, you might have been thrown off a little bit by some of the things he said. So let's start with one of these that's already in your notes, 3 to the negative second power. We already did that on the previous page. 3 to the negative second power is 1/9. And how I generally think about negative exponents is I just go, oh, I gotta take that to the denominator. I gotta move it to the denominator. If you have a negative exponent in your denominator, then you just take that and move it to the top. Okay, that's how I think of negative exponents. But there is another way to think about them, and it is useful for when you have more difficult problems. So I'm gonna show you that. Here's another way to kind of get rid of this negative. To get rid of that -2 as the power, let's change that to its opposite. So the opposite of -2 is 2. So let's say I want to change that to a positive power. Okay. Well, if I change that to a positive power, it's not like I can just write a 3 down and keep going. Okay. So we're going to have to also change this 3. And you don't change it to a -3. No, we actually change it to its reciprocal. So I'm going to use parentheses to protect my base here. You could totally put them in here as well. But what is the reciprocal? Reciprocal is where you flip it. The reciprocal of 3 is 1/3. Okay, so we have 1/3 squared. Now this is just a power rule. Kind of. Okay, you got something and you're raising it to a power. I guess it's not power rule because there's no power inside, but yeah, I kind of think of it like that. So 1/3 squared is just 1/3 times 1/3. Okay, so that's how you get to 1/9. You can also kind of move this, using the power rule, you can kind of move this to the top and do 1 squared over 3 squared, which is still just 1 times 1, so we get 1 on top. 3 times 3, 9. So there's like so many different ways that you can approach these problems. So I just want to kind of show you all the different ways to think about it. Okay. But using this like reciprocal thing, let's do another one. Let's do a fractional base. So let's say we had 2/5 as your base, and we're going to raise it to the -3rd power. Now this is one where I wouldn't go back to my easy way of thinking about it, where I just take, 5 to the 3rd and stick it on the bottom. Because this would be like 1 over 2/5 cubed, and it's just ugly. Fractions in fractions are pretty confusing. So what I do is I do this whole reciprocal thing. So I change the power from -3 to +3. But that means I gotta change my base somehow. So I do the reciprocal of 2/5. So what's the reciprocal of 2/5? 5/2. Okay. Now I could write this out 3 times and do 5 halves times 5 halves times 5 halves, but I'm just gonna do the power rule. So I'm gonna insert that exponent on the top and bottom. So I have 5 cubed over 2 cubed. 5 cubed is 125. 2 cubed is 8. That does not simplify, so that's my final answer. Okay, let's do another one. Start with a base of 1/8. And let's raise it to the negative second power. Okay, let's do the reciprocal method. So I change that exponent from a -2 to a +2, which means I have to shake things up in the base. If I flip 1 over 8, I get 8 over 1. And 8 over 1 is the same thing as just 8. So this is 8 squared, which is 64. Okay, now why I'm teaching you this way of thinking about it is because eventually you're gonna get to really kind of difficult problems here. So you're gonna do a big fraction bar. And on top you have 6 x to the 5th y to the negative 10th over 2x y to the negative 8th. But we're not done. We're going to take all of this and raise it to a negative power. Let's just do -2. Okay, so when I see all this stuff, there are so many routes you can go, so many ways to solve this problem. So some people like to simplify what's on the inside right here, and 6 over 2 is 3, x to the 5th over x to the 1 is x to the 4th. Some people like to do that, and sometimes I do that, but right away, like, this is just bugging me. I want to fix it, so I do the reciprocal thing. Okay, so I'm gonna end up doing the reciprocal of the base so that I can change this exponent of -2 to +2. Now the reciprocal of this base, you literally just flip what's on top to bottom and bottom to top. So on top I would now have 2x y to the negative 8th. On the bottom I have 6x to the 5th y to the negative 10th. Okay, so all we've done is we just change that -2, that outer exponent, to a +2. In order to make that legal in math world, you actually have to make the base its reciprocal. Okay, now there's so many ways you can go from here. You can put these powers on the inside. You could do power rule. Okay, I'm actually going to simplify all of this stuff next. So I'm going to leave that power of 2 out there, kind of deal with it last. I see this 2 and 6, and that's 1/3. I got x to the 1st power over x to the 5th, 1 over 5, or not over 5, 1 minus 5. 1 minus 5 is -4. And then with the y's, you have -8. This always trips up kids, so I'm going to do it off to the side. -8 minus -10. Top minus bottom. When you subtract a negative, it turns into adding a positive, so -8 plus 10, which is 2. Okay, now I can actually use the power rule. So that outer power is going to go to the 1/3, it's going to go to the -4, and it's going to go to that 2. So this 1/3 squared is what this becomes. Or you can actually do here. Could do it like that, 1/3 squared. And then -4 times 2 is -8. And 2 times 2 is 4. But we're not done. I can simplify this stuff, and I need to fix that negative exponent. So final answer is going to end up being a big fraction. 1/3 squared is 1/3 times 1/3, which is 1/9. 1 goes on top, 9 goes on the bottom. Notice how I didn't write the 1 because sometimes you don't need to write the 1, okay? You can though, totally can. This x to the -8th, do I keep it on top or do I have to move it? Yeah, I gotta move it. Change it to x to the +8. Y to the 4th, positive exponent, we're happy, we leave it. Final answer, y to the 4th over 9x to the 8th. Okay, so I'm hoping that was helpful. That's gonna be it for this video. See you guys on the next one.